So our presenters at today's meeting are going to be Adam and Will, and they're going to talk about DIY RoboCars and their Donkey RoboCar platform?
Yeah, Donkey Car, right. Yes. So hi everybody, I see a lot of familiar faces out there. I've been to, well, I guess I've been coming to this for a few years, but I haven't been around much recently, so if you don't recognize me, that's probably why. You're probably showing up when I am not there, and vice versa. We're going to go through, so I presented on this before, I think about a year ago, right when this race started, I presented on it. We made a huge amount of progress in that year. I thought I'd just give you guys an update on this kind of racing league / open source project that Will and I have been working on. And the two are separate, sort of, in that the Donkey Car project is an open source car project, which I'll show to you in a minute, and DIY RoboCars is a racing league. It just so happens that it races autonomous cars in Oakland. Actually, there's now 20 races worldwide under the DIY RoboCars race. Will and I are involved in that. Chris Anderson started it. Will and I kind of helped run it. For those who don't know Chris Anderson, he was editor-in-chief of Wired, and then what did he do? Oh, he started a drone company called Brew Robotics about 7 or 8 years ago, and just kind of loves all things robotic. So he's been the main driving force behind all this. And we'll talk a little bit about how that kind of caused Will and I to meet and how this all happened. I thought I'd start with a demo. Only reason I'm going to start with the demo is because it's working right now, and go from there. This is a self-driving car. What I'm going to show is not self-driving. I'm going to show tele-operated. Actually, what I'm about to show you is possibly not as cool as what Evan just showed earlier. So, or whoever brought that little car in. But even so. So this is Donkey Car. It's at this point it's pretty much turnkey. You can go kind of on Amazon and buy all the parts, with the exception of the 3D printed case, which we hope you print yourself. If you don't print yourself, I can print it for you. There's other ways to get that stuff done. But pretty much it's at this point you can assemble it in an afternoon or less, get it up, start training, and it will drive. It's an end-to-end neural net. I'll talk more about that in a minute. But let me get driving. So, as you can see, it's live video. The big thing on the front is just a filter. We've been racing recently in areas with lots of reflected light, so the filter just kind of cuts that down and makes it work a little better. So this is kind of a cool little app, or this is a little web interface for the Donkey Car. And there's actually several web interfaces. There's also one to clean up your data, which is actually incredibly useful. And basically, this is how you collect your training data. You can drive from here. If you have it on a phone, you can use device tilt and all that kind of stuff. Basically, I can just kind of tele-operate this little guy. And it moves pretty fast, as you can tell. And if you see Will drive this thing, it's actually crazy how well he can drive this just from this interface.
What's the interface you're using?
This is just a web interface, a web server on the device, Tornado web server. Oh no, this is a joystick right here, a virtual joystick. So it's actually nice on a phone. You can actually kind of virtual joystick around or do tilt, or you can actually connect a physical joystick, which I do because I'm not as good as well as at using the app. But then you can also put it in autonomous mode and that kind of stuff from this interface. So it's pretty cool the way you get started. Now, if you look at this little screen right here, it looks really grainy. And the reason for that is that the images being sent are actually 160 by 120. And that's most notably because it reduces bandwidth, but also it reduces the size of our model, or of our neural net. And we'll talk more about that later. All right, with that, I'm going to call it, I've successfully shown motion, so I'm going to call the demo done. Didn't actually train it on anything, so it's not going to do anything interesting. So we'll go straight to the presentation. All right. So Will is on remotely. He lives in Oakland. And so I don't I'm not upset that he's not here. And we've actually been talking. We've been talking at a lot of events lately, so I'm sure he just doesn't want to drive all over the Bay Area all over again. But I'll kind of run through the overview of the platform, and then he's going to dive in at the second half and go through the software. But basically, this is how to turn an RC car into an end-to-end neural network driven car. It's of course open source, fully documented. It's all on GitHub, with the exception of a few things which are actually on Thingiverse, just because it's a better platform for stuff that's 3D printed. And pretty much, like I said, it's pretty much turnkey. It's under continuous kind of heavy development, so it's getting better most of the time, and gets worse often as well, but not as often. And I thought we'd kind of go through kind of the history of the platform, which is, I think, interesting in and of itself. How the hardware and software works. We're going to go through kind of how to train a model, and then what we're doing next. It's just probably worth mentioning right now is that we don't know how many of these have been built. We know the number is north of 500, because that's actually the data we have. It could be twice that, but it's a pretty substantial number of these at this point. It's kind of become the platform of choice for building, sort of a TensorFlow-driven car. So Will and I met 14 months ago at a hackathon that Chris Anderson threw before he knew it, before it was even called DIY RoboCars. He said, let's do a self-driving hackathon. I had, of course, like any person would do, went out and I built a car, got an autopilot, was ready to go, and then he said, like 2 weeks beforehand, he said, no GPS. So I was like, okay, let me scrap that and go to Vision, and brought this car. Actually, this car was literally all in pieces, and I spent most of the day assembling it physically. And then Will came down and sat next to me. We started chatting about the platform. I said, can I help? And I said, sure. Not knowing, of course, that by helping, it would mean ultimately you probably did most of the work. So it was fantastic. And the reason he was interested in this, which was different than me, I'm interested because I come to this meeting. I like robots. I can't help myself and stuff. And there's a new robot challenge. He actually had a much more noble cause, and he can talk a little bit about this. He actually ran for the BART board, kind of on the platform that you could replace. That BART is far too expensive. The cost per track per mile is excessive. If you could dedicate lanes and use kind of self-driving minivans, you'd be in a much better situation. And while that seems very kind of normal these days to talk about that kind of thing, I think 18 months ago, it actually was not that normal to talk about that kind of thing. And basically, he did not get elected, but he talked to his constituents, and he asked why, and they said, well, they didn't think it was possible to replace a train with a self-driving minivans. And I'm sure he can correct and give more details on that as he comes on later. So we went to this first meetup, and the car at the end of the day could do two things. It could drive straight, and it could turn left. It could not turn right, as it turns out. And we had this little lovely video showing how awesome that was. But we, like I said, we had a pile of parts at the beginning of the day, so our Python code would have grown by probably 20% if we made it turn right. And you notice that one car there is actually doing pretty awesome. That's a guy named Atavio Good. He's a Google employee. He built a really cool end-to-end neural net. Will went and found him, started chatting with him, took a look at his code, and started that's sort of the basis of the donkey car. So we have a lot. We appreciate what Atavio built. So it grew. Now you're actually starting to see more than one car. Will had a car. This is his, and that's mine. We found this awesome warehouse, which is looks like it's out of Cyberpunk movie, which was super cool, including the puddles on the floor and everything associated with that. And literally, you can start. It looks. We were just like huddled on the floor. We had ribbon down for a track, and that was our first race. And our first race, neither Will nor I got around the track. Only one car did. And that was actually a car based on computer vision, actually by a computer vision startup that did the race.
Adam, that's yours, the yellow one?
Yeah, that was my first one. And actually, I planned on bringing that, but I only had 2 hands and I had 2 robots, and I didn't bring a third.
Marco, you use that chassis, haven't you?
No.
No, his is actually cooler than mine. Yeah.
Giant.
Yeah, and by the way,
He had a
Marco
new-
also goes to occasionally to go. Hasn't in a while, but the competition was not good enough for Marco, I think.
I don't have enough time. I was actually planning on coming basically last week.
But now, no.
It's every 2 months now, so it should be easier. So, so you can see this is kind of the beginnings of us driving and racing. And actually, in the second race, we did finish. Will and I raced in the second one, and we actually got around the track. And it was one of those things that was remarkable that once it started going around the track, you could just sort of leave it there, just drive endlessly around the track, which was, I think, pretty cool and pretty stunning. So about 3 or 4 months into it, Will and I realized that we wanted to make this a standard platform. People were asking us, how do you do this? How do you build more? And we said, all right, we're going to base it on a really inexpensive car, which this is called this little car here. I'll grab it again. This is called a Magnet. It's about the cheapest kind of decent platform we could find. You know, it's somewhere between $70 to actually about $300, depending upon on where on the stock on Amazon. I think we have single-handedly made the day of whoever made these things. There's been times it's been stocked out for months.
I'm waiting for 2 right now.
There you go. We've been trying to figure out other ways of making cars available. I'll talk a little bit about that towards the end, about building other platforms, making it work other ways. Many more people have built the Donkey platform. Actually, this picture in the middle is pretty cool. This is 20 cars were built by the San Diego Robotics Club, and they now have a DIY RoboCars league.
Nice.
It's one of the 20s. They're kind of the second big group.
Wow.
And we actually added, when that happened, we added a pretty core engineer to the team, a guy named Tom Kramer, who's just incredible. He built the simulators and all that kind of stuff. And he actually did this race. Actually, this is worth kind of checking out. It's long, so I might skip to the end. But he did a bunch of stuff around training on obstacle avoidance. You can see here it's avoiding cones. So this is not. There's no intelligence here beyond. I shouldn't say there's no. It doesn't know that it's a cone. It just knows that when it sees a cone, when it sees that thing, it should turn. That's all it knows. So it's literally just a behavioral cloning training exercise, and you can do a lot of really cool things with that. Let me see where.
Jesus, that is amazing.
It's a little faster. There's one here at some point where it's 2 cars. All right, this is max speed. Let me go back. Yes, so it gets going pretty quickly. This is kind of going at a pretty fast clip. We're maxing out in the race league at about 3 to 4 meters per second, or 3 to 5 meters per second. That's extremely fast. It's one of these things where we're running out of traction budget, and the tires are no longer sticking to the ground, and we have to start having techniques to kind of keep things on. And I should say that's not just Donkey; that's other cars in the league as well. There's some pretty remarkable other cars in the league that are not based on Donkey.
Were you still doing the technique where you were using a web server? Because at this kind of speed, I can't imagine getting the images up and back and processed and acting on them.
So when you're, so the way it works, so in the, I think you may remember the presentation we did a year ago.
Yeah.
We were actually sending the data to Amazon
Correct.
and then bringing it back.
You couldn't do this.
We're not doing that anymore.
Yeah, okay.
So the web server is now running on the car.
I can't believe you
Um,
would be able to.
Yeah, and I think Will is the only person that can actually race with the phone still. I use a PS3 controller, and that's the only way I can get the speeds that I need in order to race effectively. And that's only important when you're doing throttle control. If you're not doing throttle control, you can just set the max throttle. You can just set a single throttle and just go. So you can actually train really slowly, which is what I use sometimes. It's kind of cheating. You train really slowly, you get a lot of really good images, and then you just set the throttle at one level and you go. All right, so I'm going to go past it. So here's kind of the results of a lot of the races. I compile kind of all of our racing information, and every time we have kind of an interesting change in speeds, we update this and kind of show where the details are. There's this kind of there's in theory this battle between CV-based approaches and ML-based approaches that we talk about at these things. Although these days those are merging more and more. Some of the Donkey Dev stuff actually uses CV techniques to pull out features and that kind of stuff from images. So, you know, certainly just like any real car, you'd use CV to do certain things it's really good at. Use ML to do other things it's good at. Ideally, you're bringing in other sensors to do other things they're good at. For example, one of the racers, actually a guy who's, I think this car right here, so the second fastest car on that day, actually uses a Kalman filter where he brings in what's it called? He brings in gyro data so that he knows if the car is spun out a little bit. So because oftentimes when you're racing really fast, you can't see the lines anymore. So he's able to know which side of the line he's on, so he can get back on track. And it's the way that he's gotten to kind of next level performance levels.